For our next talk here, I'm excited to introduce Harish Krishnan, who's going to talk with us about where continuous integration meets application security. He's got over 10 years experience in the field. He's a product security champion for Intel Security. Does a lot of security architecture reviews, using threat modeling, pen testing, a variety of other techniques. And as we talk more and more about continuous integration and rapid software delivery, I think this is a very, very good topic. I'm going to turn it over to him. Please remember at the end of the talk, if you can go in and fill out the survey to review the presentation. That feedback's valuable both to the conference organizers and to our speakers. So your time's appreciated on that. With that, I'm going to turn it over to Harish.
Thanks, Aaron. Hello, can you guys hear me? So before even this conference started and the schedule was posted online, I was always thinking I should not get an afternoon slot, and that took close to lunchtime, and unfortunately I got the same slot, so I'll try my best to keep you all awake. I'm Harish Krishnan, as Aaron said. I'm a product security champion at Intel Security. I'm very passionate about security. I'm a learner. I always try to learn new things, new tools, new security tools, new exploits. Security is what I do. Vasant Raju is the other co-author of this paper. Unfortunately, he could not make it. He's my counterpart. He works in India office. He's a software developer, and he's also very much interested and passionate about security. So what I'll be sharing in the next half an hour or so is purely based on our learning and experiences, and more importantly, the success that we have seen by doing this, by setting up this infrastructure, and would like to share the same with you guys so that you can do the same thing and get benefit out of it and see the same success as we have seen. So I'll start my presentation with this simple question. How confident are you when somebody asks this question, how secure is your product? Is your product secure? We all are engineers. We all work on different products in different companies. And if somebody asks this question to you today, how confident are you is your product secure or not? What would be your answer today? Just give a thought about it. Just be thinking on that. So in today's presentation, this is the agenda that I'll be going over. I'll start with the problem statement. So what is the problem that we're trying to solve? And following that is continuous integration. What is continuous integration? I'm sure most of you might be already using it. If not, that's fine too. We'll just discuss what it is. I'll just go over a brief description on what it is and how we work with it. And what's application security? And I'll just talk about it a little bit. And most of my time I spend on the next topic, which is the security tools. So what are the tools that we use for application security, right? And then once the tools are done, then how do we integrate those tools with this existing continuous integration and see how we can get benefit from and the advantages and the success that we have already seen. And what do we get? So I'll end with what do we get. So, okay, we have the continuous integration, we have the tools, we integrated them, so what do we get? I'll just share the successes that we had and let's see what do we get. Problem statement. I'm sure most of you agree with this, and this is one of the big concerns, and it's still there. That security comes last, and I'll just take an example. The previous projects that I was working on, it's a year-old project, and we get the requirements. We plan for the requirements. We design the requirements. We implement the requirements, and we test the requirements. And once we reach, say, a feature complete or kind of thing, once we reach a major milestone, that's when we start thinking about security. And then we say, okay, we need to perform some kind of specialty testing, like performance testing, security testing, towards the end and not at the beginning. And we never think about security from the beginning. So what's the problem? Is there a problem with that? Definitely, right? Like any software quality issues, any bug that's found late in the project lifecycle, it's really difficult to fix. A lot of time consuming, and let's take an example of a security issue, right? So the software that we write, we use many different third-party libraries when we build our software. And say we are almost releasing our product, and then we realize there is a vulnerability in one of the library that we consume. And a simple fix would be to just replace the library, install the new library which has the fix. That will be the pretty straightforward fix. But what if the new library which has the fix is backward incompatible with the one that we were using? And then we'll have to refactor our code in order to make it work, and you end up spending a lot of time, or sometimes you defer the bug and say, okay, I'll take it in the next release. So it's late and time consuming, and a lot of efforts needed. And everybody agrees to the fact that security is important, but the thing is we all ignore that during the product lifecycle. So let's talk about continuous integration, right? So I'll just go briefly. I'll not talk in detail about this because my focus is on the tools and how to integrate and how to get benefit from those tools. There's a Wikipedia definition. I'll give an example. In simple terms, I work in a team with 15 engineers, and all of them write code, and all of them checks in code. So whenever I check in code, I have to make sure the code is not broken. When I say when code is not broken, it's not just compilation. We also need to make sure it compiles successfully. It also runs all the tests successfully, and all the tests are passed, so that when next person checks out and he uses the same code and he checks in, and he also needs to make sure the same thing, right? So we all work for the same product, so we are all working on the same source code, same product, and everybody checking out the same code. So they have to make sure whenever you check in, make sure you're not breaking anything. So to help with that, there is this continuous integration softwares available. There are free versions and the commercial versions too, and it's a framework. The continuous integration software is a framework which does not do anything on its own. You have to tell it everything from scratch. So you say, this is where my source code is. So it knows where your source code is, and it polls your source code. And you say, this is the command to build my project. You provide the instruction, and you say, this is the command to deploy my application, and this is where my unit tests are, and this is the command that you need to run to run the unit tests. And same thing for integration tests. And this is where you need to put the report, and this is where you do. And basically, if you see, you give all the instructions to the continuous integration system, and it does everything automatically now. It just takes input from us from scratch, and then automatically it will take care of polling the resource repository, checking out, doing deployment, whatever we have told to do. So that's kind of a rough idea of what continuous integration is. There are so many softwares. As I said, there are so many continuous integration softwares, and the one that we use, is TeamCity, and it's a commercial software. So that's about continuous integration, just to get an idea what continuous integration is. And let's see what application security is. In simple terms, anything that you do in order to secure an application, it's application security. What are the measures that you take? Okay, you run different tools. You hire a external security audit who comes and does a security audit, and you perform threat model, you perform security review, security audit. Whatever you do in order to secure your application is considered application security. And there's a Wikipedia definition there too. So this is just giving an idea what they are. And so from this slide, I'll be spending more time on each of the following slides. And these are the different security tools that we use in order to for application security. And there are different categories of tools. One is static analysis, and in static analysis we use different tools. Dynamic analysis, we'll talk about these things, what these are in the next slides. And there's also a different category called third-party library audit, and we'll also see what they are. And and we'll talk about these tools in detail. Okay, static analysis. Static analysis is analysis done on the source code directly. So there are, as I said, there are many tools which does analysis on the code, and different tools requirements are different. Like for example, there are tools which run on the source code directly and gives you a result, and there are tools which actually compiles the source code into an object code which it understands, and then it performs a test on that object code, and it gives the results. And when we run static analysis, it runs both quality, which is general bugs, general quality bugs, and security issues as well. So these are the two tools that we use. Coverity, I'm not sure how many of you have heard about this. It's a commercial tool. It's a static analysis for C, C++, and Java, and we use it for Java. It's a very good tool. It's a very good tool. We have been using it from past couple years. As I said, it's commercial. It does have so many configurations which user can. It does provide user with a lot of configurations where he can choose what he needs to run. He says, okay, I need to run just the security checkers. I need to run just the performance checkers, and a lot of configurations which users can use and run the scan against. And the other one is find bugs. I'm not sure how many of you have heard about this tool as well. And this is specifically for Java, and it's open source. It's free tool and very popular static analysis for Java on the Java side. So this is this as I said, this is specifically for Java, and even this provides a lot of configurations, and it's pretty easy to configure and run the static analysis with security checkers enabled. And I'll be talking more about how to configure find bugs and how to integrate it with the continuous integration system, and see how it can benefit us. So this is one of the find bugs configuration. There are so many configurations. I'll not be talking about everything. I'm just picking few important things that we do, and what's needed for the security. So this is a simple XML file. In find bugs, there is something called filter files, where you create a filter and say include this filter or exclude that filter. And our scope in find bugs is security for now. That's what we are doing. So our scope is just to report security issues. So when I run this tool against my application, I would like to see only security issues. And this is how you do that. So there is a filter file, and there is a find bugs filter element where you add a match element and then say bug category is equal to security. And there are so many different bug categories like performance, correctness, or so many other different categories, but what we are interested in is security. And this is how you configure an XML file. A filter, it's called filter file in findbugs language, and you just say this is just run security category. And next, findbugs configuration. There are different ways you can run this tool. And out of box, you can run from the GUI, you can run from the command line, and the one that we use is from Ant scripts. So Ant, if you have used it, if you're not, it's fine. Ant is a Java library. It's mainly used for building Java applications, and Ant script is also available. So you can just run this script, and the tool runs the scan. And if you note, we are just saying that output should be in XML format, and the include filter is equal to this filter. This is the filter that we created in the previous slide. So basically, we're saying run scan and provide me an output with an XML file or XML format, and include that filter, meaning just report security issues for me, and you just run it. So those are the two simple straightforward configurations in the find bugs, and let's see how you can integrate find bugs into continuous integration system. So this we have seen. It's the same thing. Somebody checks in the code, the source repository, the continuous integration software. In our case, it's TeamCity, or if you are using some of the software, polls the source repository, and it knows there is a new code, checks out the code, and build if needed. So the reason I'm saying build if needed, because different tools requirement are different. Like for example, I said find bugs. Find bugs just directly runs on the source code. It does not require you to compile the source code. Whereas Coverity, it compiles our application into an object code, and it runs scan against on that byte code, on object code or byte code, whatever. So that's the reason you can choose whether if you want to build your application or not. So once you build it, then run static analysis. So when I say run static analysis, all you do is run that Ant script, what I showed you. It's simple Ant script. We very specify what's the output file, what's the filter file, and where's the source code, all those details, and you simply run that Ant script, and that's one of the build steps. And one of the main important step is analyzing the results. So when we manually run these tools, you just run the tool, you get the results, you manually review the results, and you say, okay, are there any false positive, are there any issues, real issues or not? And it's easy when you're doing manually. But when you're automating it, we are trying to automate end to end. So automatically you need to analyze and see if there are real issues or not. So the way we do is, again, it's pretty straightforward, simple. If you remember, the output was XML file, so we know the output is XML file. And we also said include filter security, meaning we also know in that XML file if there are any issues, then it will be only security issues. And if there are any issues in an XML file, the way it stores, the way Findbug stores issues is within this bug instance element. So there will be an element for every bug that it finds. There's a bug instance element, and it says what's the category. In this case, it's obviously security. What was the class name? What was the file? Where was the issue found? And all those details. And what we do in this analyze step is basically program it. This is the only software that we write. If you see this, there is continuous integration, and there is this Findbugs tool which is free, and there's Ant script which is already available out of the box. You can run it. That's the only piece of code that you write to just programmatically parse the XML file which is output and see if there are any bug instance elements. If yes, then yes, fail the build and notify the users. So the way it works in TeamCity is when you fail the build, the loop, it's called loops, the loop becomes red, and we know who checks it. Everybody will know who checked in the code and why, what was the new code that was checked in, and why it failed because of the results, and go ahead and fix the issue and then do the things. And this happens every time. And this is how we integrate Findbugs into our continuous integration systems. As I said, we already have the complete automation framework from the continuous integration software itself. And we have these tools which has the capability to be run automatically via Ant scripts. And all we are doing is just integrating them. We are not spending any time. The only thing, as I said, you write that code to parse the XML and see if there are any bug instance elements. That's it. You just run this, and then you have continuous integration running your static analysis. Sure, please.
So it fails the build.
Mm-hmm.
So does that mean the build is broken for everyone? Or do you have a way of basically testing it before?
Sure, exactly. That's a good question. In TeamCity, we have something called remote runs. So basically what that does is, from your IDE where you write the code, you have a plugin that you can install, TeamCity plugin. And whenever you write code, before even you check in the code, you can say, do a remote run. So basically what it does is you can say do a remote run and choose what loops that you need to run. In this case, I want to run Findbugs loop, right? So it will not check in the code, but the server, TeamCity server, takes the new code from your IDE, runs the same set of tests and give you the results. So that way there's something called remote run. So that way that's called pre-run, pre-check-in runs. So you do it, that's how most of us do, and that's a process that we follow. Before even check-in, we have to make sure our pre-check-in, our remote runs are passing. Only then you go ahead and check in the code. Did that answer your question? Yeah. So that's about static analysis. Let's talk about dynamic analysis. This is Wikipedia definition. Dynamic analysis is the analysis that you run on the application which is already running. So in static analysis, it was static. The application is not running. You're just scanning the code. Here, the application is running. It needs to be up and running, and you need to interact with the application in order to get some output. You send some input, you get some output, analyze the output, and that's how you do dynamic analysis. So these are the two tools that we use. Nessus. I'm not sure if you guys have heard about this tool. This is also a commercial tool. I believe this is from a company called Synopsys now. It's Tenable, sorry. I think it's a company called Tenable. So Nessus is also a vulnerability scanner, a network and application and web application security scanner. It's also a very great tool. We have been using this from a long time. So the way that tool works is you just point an IP address and say scan that machine, and it's just one way. It's not always that's the only option. It's just one way. Point an IP address and say scan that machine, and then it scans that machine, identifies all the ports that are open, and for each port it sees what service is running, and it identifies, okay, there is a port which is web service is running, and then it performs web app specific tests against that port, and that's how this Nessus scanning runs. And the one other tool that we use is XS3 scanner. This is an in-house scanner. It's a scanner that's authored by me. It's a web application scanner. Most of the Intel security product teams uses this tool. So initially when I wrote this, it's written in Python. Initially when I wrote this tool, it was just focusing on cross-site scripting, and that's the reason I named it as XSS scanner, so XS3 scanner. But later I added many more tests. This was a very old name. Later I added so many tests like CSRF issues, SQL injection, security header related tests, HTTP header security related tests, and so many. So this is just a proprietary tool that we use as part of our continuous integration as well. And I'll be talking more about Nessus and how to integrate that with the TeamCity.
Have you thought about putting that on GitHub?
Which one?
The tool you wrote.
Actually, no, but
You should.
yeah, there's no reason why I should not, but I haven't thought about that. Yeah.
Is it tailored to your specific application or is it general?
Yeah, so that's a good question. So the reason I did not put on GitHub is because the scope, when I wrote, the scope was my application. I was not writing for generic audience. It was just for our one of very big application in McAfee or Intel security. So yes, it's specific to one of our Intel security product. And that can be made generic to it, but just that it's out of my scope. Yeah, thanks for letting me know. Yeah. So I know if I go that route, there are so many things that I need to. So I'll be talking more about Nessus. How do we configure, and how do we integrate that with TeamCity? And if you see, whatever tools that we use today, it can be continuous integration, TeamCity or Nessus or any tool. They all provide a mechanism to be automated. Like for example, whatever you do manually, like you log into a server, you do some things, perform a scan, download a report, all these things you don't have to do manually anymore. They all provide API. Every tool provides APIs. Even TeamCity provides APIs. So whatever you do on the UI, you can do it through scripts by calling those APIs. And Nessus is no different. So Nessus provides something called REST APIs, and using those APIs, you can just simply do whatever you can do on a UI. So you can say log into the machine, connect to the server, do the scan, run the scan, create a new policy, download the report once the scan is done, all those stuff. So it provides Nessus APIs. So in order to use those APIs, we have to write code. So we have to write code in order to integrate with those APIs. We have to look at their SDK and know how the APIs are implemented, and you need to call those APIs. And fortunately, there are some frameworks already available online, which is free, which already does that work for us. So in our case, we use something called NesRest. It's a Nessus REST API. It's a Python framework. It's free to use. So what it does is it uses those REST APIs and just provides an abstraction layer for us so that you can just use this Python tool. Whoever is good at Python, they would just love to use this framework instead of calling the REST APIs directly. So this is the framework that we use, and as I said, it's free, and it already integrates with all the REST APIs, and all you have to do is just call the respective methods or functions that you want to do. And so here's some example of that, right? So this is the Nessus Python framework. I hope a few of you know Python, but if not, my apologies. It's so straightforward. All I'm trying to show is it's so simple, and you can do the same thing with other tools. It's not necessarily the same tool, just that the process is same. And so if you see, we just call Ness, we just import that module and call ness.scanner and provide the URL details of the scanner. You just say URL of the scanner and keys. So nowadays, if you see the tools that are coming out, like Nessus is one example, or Amazon Web Services or whatever, you don't use username and password when connecting to those APIs. All you do is like keys. You work with secret keys or access keys. And Nessus also has those keys which you can get it from the server and use in your scripts to connect to the server. So it's just like 2-3 lines of code, and you're connected to the Nessus server. And next, what you do, once you connect to the server, you just say scan.scan run, and it will just run the scan with obviously some predefined policy settings. And once the scan is run, you say scan.download scan, you just get the results downloaded. So it's pretty straightforward. So there's the API, there's framework, use this framework, and it's already automated. So it's already available there. All we have to do is just use it and integrate in our TeamCity or whatever continuous integration setup that we use, and download the report. And next, again, same thing, same process. Let's see how to integrate Nessus into this continuous integration system. How do we do? Same thing. User checks in the code, check out the code, and deploy or install. So this is different from static analysis. So if you see, for dynamic analysis, as I said, the application need to be running. So once you check out your code, you need to deploy your application. So either deploy as in you can install and make a server. In our case, the product that I work on, the application that I work on is a web application. So we just check out the code and deploy the application which runs on Tomcat, and the server is up and running. And then I say run dynamic analysis. The way I run this dynamic analysis is use just the Python automation script which I showed in the previous slide. Just say run scan against that machine where my application is running, and that script is actually talking to Nessus server, which connects and says run scan on this machine, and automatically it runs. And once the result is out, this is where we need to spend a lot of time. So as I said, analyzing results automatically is a bit trickier. Manually doing it is always easy. You can decide what's wrong, what's correct. But in automatic, the way we do it is same thing. They use the same framework and download. Once you download the report, parse the report. The report is in XML file, or it could be any format. I think it's an XML file in our case. Report, parse the report, and then get the targets. So when you run the scan, you can mention multiple targets. So you just get the targets on which the scan was run, and then say target.vulnerabilities. So this is not the exact API calls, but just to get an idea how simple it is to get the vulnerabilities. So you just got the list of vulnerabilities that were found by this scan, and that was reported in that report file. And now you can decide based on that vulnerability whether is that critical or not. So how do you decide whether it's critical or not, right? So the way Nessus reports issues are based on severities, like severity 1, severity 2, severity 3, severity 4, severity 5. Basically it's high, medium, low. It starts from informational. Info, low, high, medium, and high categories. So you can choose which you want to look for. In our case, we actually ignore informational, and the reason we ignore because we have been running this tool, and we know what the informational type of messages that it provides in the report. So we ignore information. Anything other than informational type of issues that are reported, then we say it's an issue and mark the build fail or the loop turns red, so that somebody goes and look into it and say, okay, yeah, then I have to fix that, or then it might be a false positive. Then you have a suppressing mechanism where you can hide the false positive.
Question.
Sure. Hey.
How does Nessus know the set of URLs it needs to scan against? Is it something event-based? Every time you make a click, it makes an account for that URL and does the scanning, or it can crawl on the overall?
So mostly it's a network scanning tool. So as I said, you just provide the IP address of the machine, and it scans that machine and identifies all the ports that are open on that machine, and it checks which service runs on which port, and it identifies, okay, 8443 is a port where web service is running, and then it runs web-related tests on that port, and that's how it identifies. And you can also configure. You can say, instead of providing IP, you can also give the application itself. That the latest tool provides that. It's a dynamic analysis tool, right? Because the application is running, and you specify what your web application details are, the login credentials are, and then it automatically performs those tests on those tools, and you get the report out of it. Did that answer your question?
Yeah. When we say dynamic, is there any dynamic action that user needs to perform, or?
No. So the dynamic is the application is running. It's live. That's called dynamic. So your application, say web application, is running. In static analysis here, it's not running. It's a simple code. Here, that's the reason we call it as dynamic, because it's running live, and you're sending inputs, you're getting outputs from the live server, and the tool analyzes the report, and then reports the issues or something. Somebody had a question, sorry. So that's how we integrate Nessus, and like we have two loops. One is for static analysis, which actually uses those tools, and one is for dynamic analysis, Nessus, and does the same thing. And we have done the same thing for our XS3 scanner, which is a proprietary in-house tool, and we get the report, and everything is automated end to end. And the next category of tool that we run is third-party component security audit. So the software that we work, that we implement, always depends, not always, most of the time we use third-party libraries. So just to give you an example, the product that I work on actually consumes 70 plus libraries. So 70 plus third-party libraries is used by our product that we build. And whenever we release the product, and if there is any issue, if there is any security vulnerability in any one of the third-party library, then our application is also vulnerable to that vulnerability, because we consume that library. And so the way it used to work before, when I was doing this audit manually, is you just go through the list of all the third-party libraries, go to each of the third-party libraries website, and see what the latest version is, what are the different security vulnerabilities, and the version that I'm using is vulnerable to any of the CVEs, which is common vulnerability exposures. If yes, then okay, update to the latest version. It's a time-consuming task. As I said, 70 plus libraries, manually doing it, and it's time-consuming and not efficient. Say I did it today, and if there is a new CVE or new vulnerability that was published tomorrow, I'll not know about that until I do the next audit again. I'll have to do the same audit, and then I know, okay, there's a new issue that was found. So that's a pain, that's a problem if you do manual audit. And fortunately, there is a tool called from OWASP. It's called Dependency Check. So OWASP is a online security community specifically for web application, very popular community. Open Web Application Security Framework project is the full form of that. So they have come up with this tool, and this tool does exactly what I was doing before a couple of years back, which was manual security audit of third-party libraries. So all it does is, I think this tool is for Java, and I think for .NET. So we use it for Java because our application is Java. So what this tool does is it identifies all the libraries that we use, and also the dependencies of the libraries and all the dependencies, and scans those libraries and identifies any security issues that are out there in those libraries, and then it calls it out. And the way it does is, it scans our local files and compares it with the online NVD. There is a website where you get all the latest CVEs that are posted, and it gets those details I think weekly once or something, and then it compares, and then that's how it makes sure it's checking for latest vulnerabilities. And this is one of the awesome tools that we use. Highly recommend. It finds issues and then notifies you, and we have found so many vulnerabilities in the libraries that we consume. So this again, there are different ways to run it, and we use Ant because we are Java-based application, so we use Ant. It's again simple Ant script, and you just, with a dependency check element, Ant task, and you just run it. You just say, this is where all the jar files are, and the report format is XML, and then run the scan, and then it just searches for any vulnerabilities in the applications, in the third-party libraries. So same process. Just wanted to highlight, it's so easy to do. The tool is free. If you already are using continuous integration, then this tool is free. It's already automated out of the box, which it means it provides Ant scripts or any other command line interface as well. And then same thing, somebody checks in the code, check out code. So in this case, I mean, you can configure in this continuous integration software, you can configure when to actually perform this test, when to check out the code. You can say for every check-in, meaning for everybody checks in, when anybody checks in, then automatically this runs. Or you can say weekly once or daily, or you can configure it, or you can say on demand. So it will not run until you manually go and do it. So in our case, we don't do it every check-in because we don't expect to check in third-party libraries every check-in. So we do, I think, weekly once, I believe, or once in a sprint or something. So check out the code and group the libraries. Basically, we run a small script which actually copies all the libraries and puts in a common folder, and then run the dependency checker tool against that folder. And simple, again, just run the AND script, and it runs the scan against those libraries and finds if there are any issues, then it will just flag them and analyze the results. Again, same step. You just do the same thing, same process, but you need to automatically analyze the results. Since in this case, you programmatically parse the XML file, that is the output of the report, and see if there are any vulnerabilities listed in the XML file. If yes, then yes, fail the loop, and then the same process. So we make sure if somebody checks in a new library and the library is having any vulnerabilities, then it will catch at the very first check-in. And that's how.
So fail the build.
Yes. So fail the build, as in the way we use it is the loop turns red. So meaning somebody checked in a code. When we say fail the build might compile successfully. All the tests. This is one of the tests. One of the tests failed. So not necessarily you got the thing right. So this is one of the tests, and this test failed, so we failed the build. So that's how we integrate dependency check tool. And these are the different tools that we use, and a lot of benefit and a lot of success. We have seen so many issues that these have uncovered, and we have fixed those issues as well. All are legitimate issues. Most of them were legitimate issues, and that's how we integrate this tool. Sure, thank you. I'm almost done. Thanks. So what do we get? So by doing this, what do we get? So if you think the very first initial question that I asked you, how confident are you when somebody asks the question, is your product secure? Then I would definitely say, yes, I am confident because I'm doing this. My every check-in of the code is security tested, is statically analyzed, is dynamically analyzed with the tools, and every check-in of my third-party library is checked for vulnerabilities, and it's checked on every day-to-day basis, and I'm very confident. So, and one other thing is discover and fix vulnerabilities early in SDLC. And if you remember the problem statement that I put in the very first slide, is security is always done at the last, and what this does is it helps us in finding the issues and helping us fixing the vulnerabilities as early as possible in the software development life cycle. So I would like to give few examples that we have done, that we have discovered, right? So we use these many tools. I'll start with, like, for example, static analysis. So static analysis has found so many resource leak issues in our code, and are those important? Resource leaks, definitely, right? I mean, when we run the application locally, if there are any resource leaks, we might not see the impact immediately. But if in the customer's environment, where our application is running from days or months to years, and there is a resource leak in one of our code, and then that builds up, and the application starts responding slowly, and eventually it will end up having something like a DOS kind of thing, denial of service kind of issue. So we have fixed so many resource leak issues. Plus many other issues, but I just want to call out, say, resource leak issues, because in Coverity, resource leak is considered as a security category, and we have uncovered and fixed so many issues. And talking about dynamic analysis, we used to get so many reports from customers. So customers are using our application, and they say they found some vulnerabilities in our application. And the way the report says is they ran so-and-so tool. So in this case, they ran Nessus, and they found this issue. And this used to happen like a couple years back. And they said they ran Nessus and they found issues, and we analyzed the issue and we say, yeah, it's an actual issue, we should fix it. And we fixed it. And now it's 0, because we are already running the tool on a daily basis, on every check-in, and we're making sure if there are any legitimate issues, then we fix it immediately. And we have not got any issues so far from past few years from the customers, from running dynamic analysis. And what other tool? Like dependency checker. There are a lot of examples there. And we run that tool, and we have uncovered so many vulnerabilities in the libraries, because what we see is the library that we use is latest or greatest, then okay, that's all we think. But the library might be dependent on some other library, and that is what we sometimes we ignore. And this tool helps in uncovering those issues. And so many libraries that we found vulnerable We just updated them, and we are on the latest and greatest version of libraries. And so this answers our problem statement too, and the initial question that I asked. And with that, I'll just end my presentation. Yes?
Now, what other tools have you looked at for static analysis and testing?
For static analysis, it's mostly Coverity and find bugs. I did review one of the tools before even we purchased the tool. I also participate in reviewing the tools before even saying yes, we need to purchase it or not. I think it was Checkmarks. That was one other tool that we have evaluated. And so to answer your question, mostly those are the two tools that we mostly use, Coverity and find bugs.
Okay. The static analysis, the two that I hear about most often are Clockwork and Coverity.
Come again, sorry?
Clockwork.
Yeah, Clockwork is one thing we have heard, yes. I've heard Intel uses it a lot, but we never use it. We've never used it.
And how about other products like Nessus?
Oh yeah, there are so many dynamic analysis applications. We were using the one our company owned, which is ISECG, which is McAfee before. We had a scanner, our own scanner, MVM, McAfee Vulnerability Scanner, McAfee Vulnerability Manager. So that's a web application scanner, but that became end of life. And we used to use this HP QA Inspect. There's another tool from HP. It's a web application scanner, dynamic web application scanner, but we stopped using it from a long time back because of some other issues. So as of now, we use Nessus and the homegrown tool that we have written, that I have authored. And we are just looking for tools. I mean, we are not just stopping here. And also just to let you know, these are not the only tools. This is, the idea for presenting here was the process. The tools can be different based on your requirements. You can do the same process. If you're already doing continuous integration, then you already have the automation framework in place because it takes care of everything. You have to just instruct it. You say, this is my source code, this is the command that you run, this is what you do to do this test, and this is where you upload the results. So if you're doing continuous integration, then you already have the automation in place. And there are the tools that I showed, there were few of them were free. So you can just get them, and they're automated out of the box. You can run them through Ant scripts, or you can run command line interface. So everything is provided to us. All we have to do is just run it and get benefit out of it. And I'm sure it'll be really beneficial and helpful. And as I said, you'll be really confident. And if somebody asks that question, are you really confident? Then I say, yes, I'm confident that I'm doing these things. And just one last thing is, security, the scope of security is too big. And by just running these tools, you cannot say you're secure and your product is secure. There are different other categories of security assessment where you perform where you actually perform design reviews, architecture reviews, perform threat models, do other kind of penetration testing, other kind of activities. But this is something which you can automate and leave it and run it on a daily basis so that you can spend more time, more focus on the actual doing reviews, threat model design reviews, and doing some security testing and penetration testing, finding vulnerabilities. Any other questions?
Sure.
Yeah. Sorry. Yeah.
So you said it was Coverity that is the tool that usually found resource leaks, right?
Yes. A lot of Coverity, a lot of resource leaks. And to be frank, Findbugs is a very popular tool, but it did not. It finds a lot of quality issues. So far, it did not find any security issues. So we cannot depend on static analysis for finding cross-site scripting issues. I mean, I don't know. I have not seen any static analysis, even including Coverity, finding any, right? So for that, you need to use dynamic analysis tools where application is running. You need to provide input, you read the output, and then see how it responds to the different possible inputs. So yes, Coverity is the one that found so many resource leaks and many more issues. That was just one highlight thing. Yeah. Yeah. And Coverity has Coverity has different categories like preview. They call it just checkers. Checkers are nothing but different tests. Like cross-site scripting is a checker, and they have some hundreds of checkers, and they have different categories. There is preview categories, where those are the checkers that are still new and they're not production quality. Test quality, you can run them and see and provide feedback kind of thing. And there is another category like standard checkers. That's what they recommend, and they are pretty confident on the findings from those checkers. There's less false positives when you run the standard checkers. Sorry, go ahead.
How long did it take you to get the security test running?
Yeah, thanks for asking. That's a good question. So most of the initial time went with the understanding the tool itself. Like for example, OWASP dependency check. So most of the time, at least a week or so, you spend time analyzing the tool, running the tool, finding the report, understanding the tool, and all those things. And so I think it took for 4 to 10, not 4, sorry, 5. I did write this in our paper. Sorry, I think around less than 2 months is what it took for us to set up this entire environment.
Where did you spend most of your time in the process?
Wait.
The setup or the analysis or the...
So let's take an example, right? Let's say find bugs, for example. So as I said, most of the time, everything is already available. The time that I spent more was the analysis part, because automatically analyzing is something challenging. It's tricky. It's not easy, because we are humans. When you do manually, you know what is right, what is wrong. So that's where most of my time, maybe I would say, spent. And the Nessus. We use that Nessus Python framework to talk to Nessus with all those APIs. And before even that Nessus framework, before we found there is a free version of it, I had spent some time writing directly with the APIs, and that was most time consuming too. And just want to call out, there's already there. It's available online. It's free for use, so you can just use it and get benefit out of it. Any more questions? Cool. Thank you.